Hello, everyone, and welcome back to Voices of Impact, an amazing initiative where us researchers can bring our job and how important it is to everyone's table. My name is Mauricio, and so far we have hosted 5 different researchers covering a wide range of topics, coming from physics to history to engineering, as well to medical sciences. So if you haven't done so, please have a look to our previous videos, which are published on our YouTube channel. And today we have with us our 6th guest, Flavia Caronna. So I will give you guys a quick introduction. Flavia studied her undergrad in energy engineering at the University of Palermo. Then she moved to the Politecnico di Milano for her master's in materials engineering and nanotechnology. She continued her career at the University of Galway in Ireland to do a PhD in biomedical engineering. Her research experience extends across multiple countries, and this includes an Erasmus Plus exchange at TU Delft and a PhD with the Marie Skłodowska-Curie International Training Network between Ireland and Germany. For the past 2 years, she has been working at the University of Genoa, where she is currently working at. And in 2025, she was awarded the Seal of Excellence for Marie Skłodowska-Curie Actions Postdoctoral Fellowship, which allowed her to get funding from Fondazione Compagnia di San Paolo. Additionally, on the same year, she was awarded the Julia Polak European Doctoral Award from the European Society for Biomaterials. So, welcome, Flavia.
Hi, thank you so much.
So I must say also a disclaimer. We know each other because we are both part of the Marie Curie Alumni Association Italian board. So in case this feels different to other interviews, it's because of that. So then I'm probably very repetitive, especially since this is the 6th interview, the 6th chat we have with researchers. But again, I think it's anyways important for people to understand not only what we do and that how it is important for everyone's life, but also we are just normal people. And that again prompts me to start with a kind of easy but personal question in the sense of, could you please just talk a bit about yourself, something you want to share with us?
Yeah, thank you. Thanks for the lovely introduction. So, talking about myself, I think after especially the presentation that you gave earlier, the one thing that come up is, and it's very clear, that I have a very multidisciplinary background. So I jumped between types of engineering during my whole education. And so a joke that I make every time is I still haven't understood what I want to be when I grow up. Because I keep changing, I keep trying. And I think that is exactly what brought me to kind of do research, the curiosity about things and about how stuff work, and about a wide variety of aspects. And I guess everything started when I was a kid. So when I was a kid, I always asked my parents to go to science museums when we were abroad. I would bring my notebook with me and take notes about, I don't know, the shape of trees, anything really. Like I just could see myself doing that in the future. And then I started my bachelor year back home in Palermo. And during my bachelor, that was in energy engineering, my favorite class was called materials, something like materials technology. So materials engineering is the first time that kind of engineers meet the world of materials. And that was my favorite class of the whole bachelor. So I thought, okay, that has to mean something. That has to that is something I want to kind of investigate more. And that's why I moved to Milan and then studied materials engineering and nanotechnology. And And then was curious about international experiences, and that brought me to work in the field of biomaterials in Galway, so in Ireland, and in a kind of a international environment. And in general, then later on, I wanted to, after having experienced the world of biomedical engineering that puts together so many aspects of science, because it puts together engineering, material science, medicine, biology, is so much, so multidisciplinary in its nature. I kind of felt the need to go a bit back towards more towards materials and the aspect of mechanics of materials, and that's how I ended up going back to Italy, where I found this kind of an interesting opportunity, and landed back here in now north of Italy, so in Genoa, working more in the fields of again here mechanics of materials. So that's a little bit about my story. And other than that, of course, as you said, Mauricio, I'm a human too, so I like to go for runs, go hiking. If you've never been to Genova, Genova is a very vertical city, so just warm up your knees if you're coming to visit Genoa, because there's going to be a lot of hills. And yeah, so like hiking, like traveling, like cooking, like climbing too, which is a great kind of activity to do here in Genova. So yeah, that's a little bit about me.
Yes, thank you very much for sharing all that. And I think it's also very nice to reflect exactly about the fact that we are persons, and how also the like little Flavia back in the day when I was a kid, all this curiosity drove you to all this. So it was just somehow we are following kind of our dreams. I mean, the story of each one might be different, and some other people will have other reasons to do research. But I think that's the same in every field, no? So that's why
Yeah.
it's just like another job, a job we normally tend to love, generally speaking, at least. So thanks for sharing that and for giving an example on that, but also on the fact that how important is mobility, no? And
Yeah.
that's also something that is encouraged by the Marie Curie program, no? So the fact
Absolutely.
that this knowledge exchange and how this your path took you here, no, to where you are now, by also getting yes knowledge from different places.
Yeah.
About that, then, could you please briefly explain what your research is about?
Yeah. Yeah. And I'll connect it to what you said earlier, because exactly this kind of interdisciplinarity and multidisciplinarity is thanks to my mobility and the fact that I could move to new countries and experience so many different environments in research, but also in industry. And I think that makes you grow as a researcher. And specifically with that, thanks to this kind of multidisciplinary background, I was recently able to get a project funded through the kind of Marie Curie Postdoctoral Fellowship. It wasn't funded by the European Union, but an Italian funder considered the project worth to be kind of investigated and researched, and funded it. So is an important aspect of a research career, because it gives you so much more than knowledge, not so much more than book knowledge. It gives you something else. It gives you context in different nations. It gives you tools. It gives you soft skills, and it opens your mind. So I'm very actually proud of having traveled, and I think recommend it to everybody.
Mhm.
But anyway, going back to kind of my research. So this project was also funded because it was a good combination between the knowledge or the expertise of the university where I'm in, or the department and the research group where I'm in right now, and my previous one, which again is very multidisciplinary. And I'm currently working on the modeling of soft composites that are bio-inspired. So more broadly is in the field of smart materials, which are generally is a big category of materials, which are intended as materials that are capable to sense a stimulus, an external stimulus, and respond to it in a certain controlled way and reversible way, which, as you can imagine, are very interesting for several applications because allow to integrate multiple functionalities together. And this would allow to not only an increase in, say, in the functions that you can achieve with a single materials, but also reduction of costs, reduction of weight of the component, because with one single thing you can achieve, this is responsive, the structure itself is responsive. And the response can be used for actual actuation purposes, so movement of some sort, but also as sensing. That could be a internal sensing of the state, but also an external sensing of an external variable. And smart materials can respond to multiple stimuli. There's many kind of types and classes, and stimuli can be temperature, humidity, can be magnetic field, electrical field. So it's a wide kind of range and very, very interesting right now. And among that field, I am focusing on, so narrowing it down and down and down, I'm focusing on bio-inspired materials, where bio-inspiration means taking inspiration from natural materials, so from nature, and trying to copy the mechanisms that nature use to achieve that normal functionalities that natural materials have and that responsiveness that they have, to try to put it into engineering materials, so into kind of everyday applications, in applications that we need in normal life. So this inspiration from nature is very interesting because you go look at materials that engineers usually don't look at. It could be plants, it could be I don't know, the woods, it could be cork. There's many kind of or it could be birds, or it could be animals, and then try to take inspiration to build a material using different building blocks that then you need it for a certain applications, because nature doesn't start from really very high kind of quality materials. It starts from simple building blocks, and then it assembles it to achieve a certain functionality. So it's the architecture that matters a lot. And so within then these kind of bio-inspired smart materials, we're working I'm working in the field of soft composites. So they are very, very soft materials that have multiple phases. And specifically, the ones we're working on are able to change their shape in response to a certain external variable. So they are shape morphing. And all of these aspects, my job is to try to model their behavior and try to understand how they respond to certain stimuli in order to be able to predict this behavior. If we can predict the behavior of this material, we can design them and we can use them in real life.
That's amazing. So uh, I I think it was anyways clear in a way to understand. But could you say like make a wee summary of your like in only could you condense it in a couple of sentences, like for the general audience, including myself, which I'm not
Yeah,
working on your field.
yeah,
Uh,
yeah, absolutely. So first of all, I'll start with explaining what composites are because it's the materials um, that I'm studying. So imagine composites in general are materials that are made of multiple phases that can be distinguished one another. So imagine a chocolate cookie. Okay, a chocolate cookie is a composite material because you can distinguish the dough phase from the chocolate chips. So those are two distinct phases. I'm in a way working on my equivalent of a chocolate cookie, where the dough, instead of being the dough, the cookie is a gel. So imagine like a jello, and instead of having the chips, we have fibers. We have long, elongated fibers in multiple directions. But now imagine that your cookie is not only delicious, but can also change shape when you eat it up, or it does actually, because whenever you cook it, it changes its shape. But and so then I'm studying it. How do I need to put those chocolate chips in order to achieve a certain shape? How do I need to tune my dough in order to obtain that shape? And then once I have understood all of that, can I then design a specific cookie, so a specific composite material for uh, my application, whether that is in biomedicine, whether that is in soft robotics. So that is how I would kind of explain it, perhaps.
I think it was very nice. Uh, so just to see if I get it correct. So first of, so you have materials that exactly prove, and I think it was a very nice way to explain it in the sense of probably thinking about myself. Like if I think about the material, I think as a one thing, no? Like this
Yeah,
one is a material, but in my mind it's like, let's say metal, this one.
yeah,
Uh, so you're working with something that is not only one single thing, but is made of different things, like you mentioned with the beautiful example of the cookie. Um, and once you have this biscuit, you also want to know how it gets affected. But let's say you have the biscuit, and either you eat it or you have it in the fridge, or you leave it outside during summer, so it becomes like softer, no? Probably, so that changes by something external in this sense. In this
exactly.
example, the temperature, no? And how will that affect? So probably now it's attached to the table where you left the biscuit, whereas if you leave it in the fridge, maybe it's now easier to break, no? So how
Yeah,
would that impact? And if we translate it to materials, probably that will also, then you will know this is affected by heat or by cold. And this
yeah,
is how we then make in the particular case of my bottle, to
yeah,
isolate, no?
yeah.
So hopefully I wasn't even more confusing than I was excited.
No, no, no.
Uh,
I think you got the point. I think the particular things of these materials or the particular functions that the materials achieve. So in this case, the ability to change their shape in response to an external stimulus is indeed given by this complexity in the structure, by the fact that we have the chips in the cookie. Otherwise, it wouldn't behave in that way. It would just it wouldn't, because in our case it's humidity the trigger, is not, for example, temperature, whereas in the case of the cookie is temperature. So understanding how that phase impact the response to the response of the material to that external stimulus is kind of a little bit what I'm trying to do in view of then being able to use these materials that are able to change their shape, knowing how their shape is gonna change.
Yeah. Okay. So thank you for the explanation. I hope it's clear for everyone. So now, from this, from what you do, then, so far in your work, could you list like 2 or more impactful things that you think that have come out of your research, or that you expect to come out of this?
Yeah. So first of all, I think one thing that is underestimated is other ideas. So, we have my main project is about this shape morphing studies, but we're working also on other smart materials, and we're raising similar questions. And that project allowed us to get inspired to continue the work on the different structure, different materials, which I think is very important when you do research, is having ideas and noting them down and continuing continuing going towards them, analyzing them. Overall, I think longer term, the aspect of a modeling framework for materials that are very complex could be interesting to be generalized as much as possible. If I can build a modeling framework that then can be used to different materials, that could allow then the development of even many more smart soft composites, just tuning the recipe, right, of the cookie. If we go back to that similarity, which I think is powerful with all the aspects that are related to modeling, which are, for example, decreasing the need for experiments on one side and the need of use of perhaps chemicals, perhaps resources that could be expensive, but also have an environmental impact. Of course, we should be aware that computational modeling has also its own impact, so it's a balance. But I think that could be kind of a long-term impact of this project. And in the kind of always kind of long-term, but more local, I think there is going to be an impact in the lab where I'm working on. And I think every researcher has an impact on their own lab, which I think is, sometimes we forget, but it's beautiful to think about, because you bring your own absolutely unique expertise and skills that wouldn't allow that if they were not there, would not allow that specific research to proceed in that specific way, which I think is also the beauty of our work, and that different people would, I don't want to say find different things, but lean the research in different direction, and so find different multiple things. So I think there will be an impact in the lab where I'm at now to perhaps expand the knowledge on or the expertise on this class of materials that also are in line with my previous expertise and work during my PhD, and perhaps again having that PhD in biomedical engineering and being exposed to the biomedicine or biomedical engineering vibrant community that there is in Ireland, that could help a lot as well into thinking about an application of these materials and thinking about who to reach out to when it's going to be the time to test these in a more applied situation and environment. So I think we gotta also remember about the impact that each of us has in their small community and small area and small groups, because perhaps if there is interest and there is more interest on this topic, perhaps we will include it in some class that we teach to students in the mechanical engineering course, that then could stimulate more curiosity. So it's a kind of a chain effect that I think it could have.
Yes. Yes, no, I think it's very valuable what you say, and from the part of the ideas. So because sometimes also we think about impactful things to something that by today is not that I cannot really touch, and it is, but this comes from exactly from the ideas, from our ideas.
Yeah.
This is how things are built, no?
Yeah.
Not like the end product comes from someone's mind, but also in general, not only from one's
No
mind, no?
one.
So I think that's why it's very worth noticing what you said, like the impact we can have in our small communities. And I think also that raises the importance of the program in our case from the Marie Curie, from what we mentioned earlier about the knowledge exchange, because probably you see something in a place that then it will flourish there thanks to what you left there, but also you bring probably a
Yeah.
seed from that place, and then it is used to flourish somewhere else because of the combination of the things, or probably we just leave and then somewhere else or someone else will take our knowledge that and then become something out of it. No, something will come
Yeah.
out of it. So I think it's very important to notice, and also especially I think for people that are outside of our research job, that to kind of understand how these things work. No, sometimes
Yeah.
I think people is kind of also get confused by TV shows or whatever, that they think is like, oh, I thought about this, I will go back to the lab, and then tomorrow
Yeah.
I have my end product. When it's not like that, it's more, and I think it's also very important. And if I remember correctly, we haven't spoke about this in the previous interviews, to say this is how this works. No, it's a
Yeah. Yeah.
collaborative process, and it's also basically that's mainly the job, no? To
Yeah.
think, to solve things, and to connect ideas from different people, and as you said, even interdisciplinary ideas, no?
Yeah.
So you work in creating better materials or more useful materials. The application might not come from you because you have the product, but then how
Yeah.
come? So then someone from the medical area will think, oh, this might be useful, and then that's how things are combined, and that's how we even progress. So I think it's a beautiful way to put how an impact your research can have or is having already. So thanks for that.
Thank you. Yeah, I want to just to add one thing,
Yes, yes.
that, as you said, research is not done alone. If you think you're gonna be able to find a lot of new stuff by yourself, perhaps in some niche areas, it is possible. But the true discoveries come whenever you work as a team, you work with a diverse community and try to solve complex issues that you as a single individual cannot have the skills alone to solve, and that's okay. And I think that is exactly why we kind of need to remember that, and remember that is still is a work that is done in community, whether there is the community of peers that you trust and that you go to whenever you need to bounce ideas and you need to define where to go together. So I think that is something that sometimes is forgotten about researchers. We don't just stay in the lab with our lab coat doing experiments. We also go outside and trying to find other people with different expertise that can help us finding things that are worth be found, let's say.
Yes, exactly. And even the combination, even I would now that you're mentioning, think, it comes to my mind like the combination of different cultural backgrounds, no? So that
Absolutely.
you're aware of something and then people is aware of something. That's why I think, as you just said, is exactly a beautiful representation of like community and
Yeah.
how we help each other. And also, so it's a job done by a community and also for the community,
For
even if it's
the
outside. And coming back to the original point at the very beginning of this chat, it's just another job, no? One that we love, but another job as important as others, but it has an impact in people's life. And I think exactly, in my personal opinion, is something that I would like to share with everyone. And that's why I'm very grateful that you bring this up. So so thank you for that, first of all. And before we grab this up, could you please share, like we thought we already mentioned this, but like about research in everyday life. So for people probably now are also understanding more this thing of community because I'm working this, no, but like how can research or use research impacts like everyone's life.
Yeah, I think so. I loved what Valeria said at the previous interview, but I'm going to be very kind of practical here. Research is an investment that the community is willing to make, and that I believe it goes to the community itself, because the governments, associations, whoever funds research, public research, wants progress to happen. And progress can happen through trial and error, through collaboration. And that progress then is the main kind of point is that it's open to everybody and can actually improve life of people. The truth of research, though, is that is incremental steps, is a big ladder that we need to kind of go up to step by step. And I feel like the aspect of this investment that sometimes is not obvious to people is, what are we investing in? Why are we investing in this? And I still remember one day that I was in the lab in Galway, and randomly there was, I think it was even COVID times, and randomly there was a visit of the lab, and I happened to be in the lab there, right? And at the time I was working with bioabsorbable polymers. So they were polymers that are able to degrade in the body. And we were doing in vitro tests. So we had these polymers in these little vials, these little bottles with water, and we were keeping them in the oven. And I had this textile that I had degraded for a while. And so I was showing the lab, and I showed this textile, but because it had degraded, initially it was a textile, and then like I shook it, and it became powder, and everybody was shocked by this. Everybody was amazed by this, and I still remember it with so much joy, because I think for me it was obvious. Like, I know that I degrade the polymer by doing this, blah blah blah. I knew the theory. It was exciting the first time, but it was fine. But even that small first step was important to, it was important to show that first step, because that could spark curiosity in people. That could spark, again, ideas, imagination, and thinking like what that could be used for, even though right now we don't have a final product. And so I think sometimes we forget what that investment is for. And I think our job as a researcher, part of our job, is to remind people what that investment is for and show what we're doing right now, even if it's not finished, even if it's a long way to go, to spark curiosity, to give back to the community what, you know, the community is giving us, you know, and we hope to give to the community in 10 years time or whatever. So yeah, I think about it like this, I'd say.
Yes, I think it's true, and also to remind the external, in a way, community, so the ones that are not working in what we do, but as you said, also into ourselves, not to, because we are amazed, but there are things that the first time we probably saw them as we were growing up or doing this path, we were amazed probably at some point, but then it just became something normal.
It becomes normal.
But when you think about it, it's still amazing, no? And it is, and that's how things start exactly. And then, as you said, I think it's also very important to remind this that research is an investment. It's not just something that, and it does have an impact in our life, and that we basically everything we have now started with an idea that are the ideas that we are cultivating. Thanks to everyone, to the money, especially, as you said, the public research. So I think it's an amazing way to end this chat, to remember that it's an investment and it's worth the investment, no? Not only because we do the job, but probably we just realize it more. And I hope also everyone realizes how the importance of this. So thank you very much, Flavia.
Thank you.
And thank you all. And I hope then, again, I would like to invite everyone to have a look at our previous interviews. And I hope you enjoy this, and see you next time with the 6th episode of this lovely project, Voices of Impact. So thank you.
Thank you.